Aloha and welcome. In today's video, we're going to be talking about the bubble sort algorithm. Bubble sort algorithm is similar to the selection sort algorithm. You have an unsorted part and a sorted part. The sorted part is going to hold the higher values in order. So if you think about your array, you've got an array that starts over on the one side at zero, the index zero, and it goes all the way up to the length of the array. And we're going to be putting the sorted values, the higher values in the higher end of the index. So if we have 10 elements, then the higher elements are going to be going towards the index of 9 if you're going from 0 to 9. So we have in this algorithm, we have an outer loop. So in this outer loop, we're going to be going through, we're going to execute n minus 1 times. We're going to compare elements side by side. So we start down at the unsorted end of our array, let's say at index of 0. And what we're going to do is we're going to compare the values at index of 0 with index of 1. And we're going to say, okay, which of these is larger? If the one in position 1 is larger, then it'll stay the same. If the value in position 0 is larger than the one in position 1, we're going to swap these values. So we're going to swap those two values, and then we're going to go and we're going to compare the next two. So the one that we just said is the larger of the two values, we're not going to take this compared to the next one. In this case, it would be the index 2. So we're comparing the values at index 1 with that of index 2. We're going to compare those, and we're going to make sure that the larger of the two is in the array at index of 2. And we're going to keep doing that over the entirety of the array until we've compared all the elements. And now we have the largest element at the end of it. So then we hit our inner loop. And our inner loop is going to be going over element 0, which is still unsorted. And we're going to go all the way up until the value of the length of it minus I, because I, we've already, you think about it, if we're on the, let's say the second time through and I is equal to 1, then we're going to have 1 already sorted. So we've got 1 less on there. So every time we go through this thing, we have to go 1 less time. We have to do 1 less comparison at the end of the array because those are the number of sorted elements at this point. So the inner loop is going to have us go slowly up until we hit, think of it as a wall. So you're going to sort up until that wall, but you're doing the same thing. You're just comparing two items that are side by side. So the item in position 0 with the item in position 1, and you're going and you're taking the items and you're pushing the larger one up. That's why it's called a bubble sort, because bubbles rise up to the top, and that's what we're doing here. The value that's higher is going to be sorting up to the top. And then when we go through it again, we find the next highest value and we bubble it up to the top. So this is going to be order of n squared because we have an outer loop and we have an inner loop. So we're going to have an order of n squared. So this is inefficient. It's not something you want to be doing on large arrays, but it is, it works. So I'll go ahead and share my screen here and pull up the text for this. So in our text, it shows the general algorithm here. So you're starting with I equals 0. You're going up to the number size minus 1 because you have to do 1 less comparison than there are the number of elements because you're comparing 2. So then you have your inner loop, and that's going to go from j equals 0 because we always start from the first element in the array because that's the unsorted end. And we're going to go up to number size minus 1 essentially, which is the same as up there because, again, we're doing 1 less than the number of elements. And we're also subtracting I because we've already, when we hit, I is essentially going to represent the number of, it's the number of times that we're going through it, but it's also the number of sorted elements we have. So we reduce the length of our traverse here by that. So we're going to do this inner loop. And in the inner loop, we're asking ourselves, is the item at location J that we're at, is that greater than the one next to it at j plus 1? If it is, then what we're going to do is we're going to take our value at j, we're going to move it into a temp variable so we don't lose it. Then we're going to take the value at, we're going to say, okay, now assign the item at j plus 1 to the item at j, or the array position at j. And then we're going to do the opposite. We're essentially flipping these two. So that's how the algorithm works. You got some basic questions down here in your participation activities, but I want to show you a visualization of it. Unfortunately, we don't have a good visualization here in our text. So I went and found a good YouTube video that explains it graphically. So when you look at this, you see the bubble sort. It's going to look at the two items, and you notice that it has a representation of a wall at the end, and that's kind of what I was talking about earlier. That represents, the index I essentially. So now you're going through it again. Your wall is one element over because you've already sorted out one. So you're comparing side by side and flipping them where you need to. And by doing that, you bubble up the last one. So then 41 is sorted. So you're slowly going through this until you've reached the entirety of the array. But yeah, so this is a good visual representation. There are other visualizations out there, but this is the one that I like the most. So there you go. So hopefully that helps you understand bubble sort. It's a very simple, rather crude sorting algorithm, but it's well known, and as we stated, it's inefficient. It's O of n squared. So you don't want to be using this for large sets of data. So anyway, if you have any questions, feel free to reach out, send me an email. Be happy to respond. Take care, and I'll see you in the next video.